Okay, problem number 9. A particle moves along the x-axis so that at any time t greater than 0, its velocity is given by the function v of t is equal to 4t minus 9t squared. If the particle is at position x equals 5 at time t equals 1, what is the position of the particle at time t equals 3? So we're looking at this and we see that we're given a velocity function v of t is equal to 4t minus 9t squared. And we're looking for the position of that. It starts at position x equals 5. We're looking for the position of the particle at time 3. Okay? So the derivative of the position, or the displacement, will give me the velocity, which means the integral, or the antiderivative, of velocity gets me back to displacement, or the position. So what we'll end up doing is we will find the displacement, the change in x, which will be equal to the definite integral. I use my limits 1 to 3. I know where I am at time 1. I want to find out where I am at time 3, so I need to find the change in my location over that time. And I can integrate the velocity function, v of t, with respect to the variable t. And from there, I can bring in my velocity function, which is 4t minus 9t squared. So the integral from 1 to 3 of 4t minus 9t squared dt. And I can take the antiderivative of this pretty easily. I have a t to the first, so I add 1 to that exponent, get t squared, and divide both it by 2. So I get 2t squared. Same thing here. I add 1 to the exponent, get 3, divide by 3, and I get minus 3t cubed. And I evaluate this going from 1 to 3. So I plug in my 3 first to this, so I get 2 times 3 squared minus 3 times 3 cubed. I plug in my 1 next, so I get 2 times 1 squared minus 3 times 1 cubed. And I subtract these two. So as I reduce this down, 3 squared is 9, 2 times 9 is 18. 3 cubed is 27, times 3 is 81, so I have a minus 81. And this reduces down to a negative 63. 1 squared is 1, 2 times 1 is 2. 1 cubed is 1, negative 3 times 1 is negative 3. So this reduces down to negative 1. And we're still subtracting these two values. So we get that our delta x here now is equal to negative 63 minus negative 1. Well, minus a negative, I can add on this 1, and that'll get me to a negative 62. So my change in location is negative 62, but I want to know where the location is, so that means that my x at time 3 will be equal to my x at time 1 plus my change in x. And that's just equal to x at time 1, well, it's in location 5 at time 1, so that's 5. And my change in x is negative 62, so plus a negative 62. And 5 plus negative 62 will give me negative 57. So my answer here is E, negative 57.